and then I'm going to share my screen. So today there are a lot of new concepts. Okay, so the very first new concept today, what we are going to learn is how to do some arithmetic expressions, so about expression conversion, like the postfix. And basically we know infix. So infix expression, like over here says, it's just an ordinary notation for arithmetic calculation. So we are very familiar. So it's coming from math expression, is it? And you do have parentheses, is it? And to put the calculation order ahead of other ones. So this is the regular infix notation. We learned that. And today, let's see another notation used also a lot in math, is we call it postfix expression. And postfix expression here, the concept is the operator is not between the two operands. It is after the two operands. So you have 5 and 7, those are two operands, and the operator, subtraction operator or minus operator, it is after it. And also in postfix expression, we don't have parentheses, so no parentheses. No parentheses, so we know that. And but a postfix expression, like over here, it explains, and it's going to be, when you do the evaluation, it's faster, okay, especially for computers. So the very first application we are going to learn is how do we convert infix to postfix. Let's see, this is next slide. This is next slide, okay. So let's take a look more of the postfix expression first to get to let us be used to the postfix expression, okay. So here we have some infix. So this is the most simplest case, so a plus b. So if you convert to postfix, it should look at AB and then plus sign. And the next one, so we all know multiplication has precedence over plus and minus, is it? So when we convert to the postfix, basically you will see the BC and then multiplication first. After that, you have the result calculated, is it? And then it's A and the result and the plus sign. Okay, so that's the second example. The third one, we have AB minus, is it? And here you have the result. And then you have the result with C, and then you have the minus sign after it. And the next one is we have BC first, multiplication conducted by the operator's precedence. And with the result, you have A and the result and the plus sign. And after that, then you have DE do the division, is it? And you have the result, then you have those two results and the minus sign. Okay, so this is another postfix expression. And here we have the parentheses, is it? With the parentheses, what it defines over here is AB, is it? And the plus sign after it. And with this result, and then you have the result and the C and the multiplication. Okay, so I think we kind of familiar with postfix expression, is it? And here it explains more about postfix advantages. So we don't need to worry parentheses. So just remember, in postfix expression, there is no parentheses, okay? But we do need to know operator's precedence. Okay, we do need to know this. And over here, this example shows, so operator then is applied to the preceding two numbers. So when we take a look at this, multiplication applied first to 5 and 2. and the result is calculated, then you have these two numbers and the plus sign, okay? So we don't no need to have the parentheses like this slide says. And then our focus is how do we do the evaluation of postfix expression? Is it so? Let me find an example so that I can explain. I can copy it. Let's see. Maybe let me use this example. Okay, use this example. Let me first annotate it so that we can kind of understand. Suppose I use number, okay, 3 plus 5 times 6, then minus 9, suppose, and divide by, suppose, 3. Okay, suppose we have this, let me do the, suppose we have this postfix expression, okay, and I will use this example to explain the algorithm, okay, how do we use the algorithm to evaluate this postfix expression. So what here we are going to discuss is about the algorithm, and this algorithm will evaluate this postfix expression. And because over here we discuss is a stack. So we are going to have a stack, okay? And in this case, the case is a number stack. So stack is a number. So the type of the stack is number. So if we use the stack class that we learned yesterday from Java package, then you need to declare like a stack. It depends on what the type is. If it's integer, then you can do like integer. And like a stack. Okay, and if it is double, then you need to do the double. Something like this. Okay, so that's the stack. And over here, the algorithm, here it involves, we call it a scan. Okay, and over here, the expression, you do need to have a space. Okay, so this, you have 3 and then space, then plus sign, then you have space. So we needed to have space to separate them for us to scan all of the tokens. And each of this, we call it a token. So we are going to start a scan from left, okay? So you scan. So the first token, basically, in the real world scenario, you're going to read this as a string literal. Then you're going to do like a string split function. You call string split, and then you will extract, get each of the token out. And you also need to convert the token from string type to number type, in this case, to do the calculation, okay? And anyway, so here we scan. The first token is 3. 3 is a number, is it? So like over here, if it's a number, you push it to the stack, okay? And I think there's something wrong with this expression. Oh, I'm sorry, this is a infix expression. I first need to convert it to postfix, okay? So the postfix then should look like 5, 6, then we have multiplication, and then we have plus here. And then we have 9, 3. We have division, okay, and then we have the minus sign. Okay, so this is our postfix expression. So we are going to start our scan here. So it's a number, so we push it to a stack. And then we continue our scan. So the next is also a number, we push it to the stack. And the next one is number, then we push it to stack. And the next one, this token, it is not a number, it is an operator. So if it is an operator, then what you need to do the algorithm is you need to pop the two number out of stack. So I'm going to pop this number out, pop the 5 out. So pop two number out. And then here you have the operator. So you apply the operator, okay? So I apply the operator. And when you apply the operator, for the multiplication, it doesn't matter, is it? But for minus or for division, it matters who is on left, who is on right. So in this case, the first number out, you put it to the operator's right. And the second one out, you put it to the left of the operator. Okay, so be careful about this because it does matter for division and minor. And we calculate the result. And it is 30, is it? And then you need to push it back. So like over here, you push the result back. And then we continue our scan. So the next token is a operator, is it? If it's an operator, I need to pop two numbers out of the operator. So I pop 30 out, and I pop 3 out. And then you apply the operator, you do the calculation, you have 33, is it? And then you push 33 back. So I push 33 back. And then I continue my scan. So number, and we know if it's number, you push them back to the stack, is it? And then the next one is operator. So if it is operator, then you need to apply the operator and pop two number out. So I pop 3 out, and I pop 9 out. And I need to apply the operator. So I apply. So this time you didn't see who is on left and who is on right when you pop the two number out. So it does matter, okay? And in this case, we have 3. And then you need to push this 3 back. We push this 3 back. And then we continue our scan. So the next one is token, is it? And if it is a token, you need to pop the two number out. So I pop 3 out. I pop 33 out, and I apply the operator, so it is a minus sign, and I calculate the result, and it's 30. So I push the number back, is it? And if you continue your scan, you will see there is nothing there, is it? So this is our stop sign, is it? So it's a stop, and we stop. And when you finish your scan, what you need to do is you just get this number out. And this is our postfix expressions calculation result. Okay, so that's generally, so what we discussed is the example, how to do the evaluation of postfix. So it's a postfix evaluation algorithm. And during the algorithm, there's a couple of things we also needed to be careful, because it's not all postfix expression is legal, is it? Suppose you have something looks like this, 3, and then minus, and then 5. This is a illegal postfix expression, is it? And so basically, this algorithm can also detect illegal postfix expression, is it? So what you can find the illegal ones is whenever you do pop two number out, is it? So whenever you have an operator, if your stack has two number pop out, that means your postfix at this point is still correct, is it? If you don't have two number, if you just have one number, and you don't have the other number pop out, that means your postfix expression is illegal, is it? Okay, so there's one place that you can find the illegal expression. There is another place, is it? So after we finish scan, is it? and your stack is supposed to only have a single number left, and you get this single number out. So then if that's the case, your postfix expression, it is a legal one. Okay, and if you have two numbers, if you have some other number, okay, 33 and 3. If you have two numbers, then that means your expression is illegal, is it? Or when you reach the end, you don't have anything, your stack is empty. That also means your postfix expression is illegal. So overall, over here, we explained the algorithm, how to use this algorithm to do postfix expression. Okay, so let's get back. So are there any questions about the postfix expression, the algorithm? Does that make some sense? Any questions? Any questions about postfix evaluation? Okay. So this is regarding postfix evaluation and using a number stack. So remember, it's using a number stack. So are there any questions regarding this? And share screen again. So on our slides, there are more about the algorithm discussed. It says after all tokens scanned, then there should be only one number. So we already discussed, is it? And I also discussed, you can also find any illegal postfix expression, okay? Okay, so in our slide, the next part discuss step by step about the postfix evaluation, and there are also some exercise, and you can try. Okay, so after class, you can try with the exercise. What next we are going to do is we are going to learn how to convert infix to postfix. Okay, and same thing here. We are going to use a stack. Using a stack. Otherwise, if you don't use stack and manually, you can also do the conversion, etc. But what we are going to do, we are going to learn the algorithm how to convert infix to postfix, also using stack. So I'm going to copy down this expression so that later on I can use it. So we have 3 and then plus 5, and make sure we have space, okay? And here we have parentheses. And we have space, we have parentheses, we have multiplication, and then we have 4, and then we have the -2, and we have parentheses, and then we also have another parenthesis plus, and the parenthesis 6. Okay, so this time we have this infix expressions, and we want to convert it to postfix. So how are we going to do this? Let me first get back to the. Okay, so here we have the algorithm. Okay, so how are we going to do the converting from infix to postfix using stack, about the stack algorithm? And this time we also need a stack. But this time our stack is different. It's a character stack. So it's a char stack. And so if you use the Java class, stack class, then what you need to do is you need to declare a stack and with the wrapper class character. So keep this in mind. Okay, keep this in mind. So the stack is different from the postfix. It's a character stack. And here, suppose we are going to keep track of a postfix expression. So this is going to be our postfix expression. Okay, so we are going to scan. So when you scan, okay, you will have a left parenthesis. If the left parenthesis, you're going to push it to stack. So I'm going to push it to stack. And the next one is also a left parenthesis, so push it to stack. The next one is a number. If it is a number, you directly apply it to the postfix expression. And the next one is an operator. And when you have an operator, you need to compare it with the top of the stack. Because at this point, the top of the stack is a left parenthesis. So there is no precedence, operator precedence issue. So what you need to do is you just directly push it to the stack. The next one is a number. If it is a number, you apply it to the postfix. Next one is a right parenthesis. And if it is a right parenthesis, by our knowledge, we know it must have a pair of the corresponding left parenthesis, is it? So we need to deal with the calculation, is it? So that means there is an operator between the two numbers. So you need to apply it to the postfix. So what over here, then in this case, if you see the right parenthesis, then you need to pop the corresponding operator out of stack and apply it to the postfix until you meet a matching left parenthesis. So we saw the left parenthesis, you just pop it out. And you don't, because postfix doesn't need a parenthesis, so you just leave it alone, okay? Just left it. And what the next you are going to see is, the next is a operator. If it's an operator, you need to compare with the top of stack. And because top is an left parenthesis, so you just apply it, or you just push it to the stack, okay? And what the next you're going to do is, you are going to see a number. And if it's a number, we are going to apply it to the postfix expression, okay? And the next one, what the next you see is an operator. So if it is an operator, and what you need to do, you need to compare it with the top. So you need to compare with the top of the stack, okay? And the top of stack, this time it's not a left parenthesis, it's an operator. So then you need to determine whose precedence is higher, is it? And so the algorithm here, it reads as, if it doesn't have higher precedence than the top of the stack, then you need to pop this guy out and apply it to postfix. And you need to keep compare. If we have some other operator, suppose plus or minus or division or another multiplication, you need to keep popping them and apply them to postfix, okay? Until you didn't have any of it, doesn't have higher precedence, then you can stop. After that, then you need to push this operator to the stack. Okay, you need to push this operator then back to stack. And then we continue our scan. So it's a right parenthesis. If it's a right parenthesis, what it says is you need to pop the top of the operator out of the stack and apply it to the postfix until you see a matching left parenthesis. You pop it out. Okay, and the next one is an operator. With this operator, you compare to the stack. The stack is empty, so you just push it to the stack. And the next one is a number. If it's a number, you apply it to the postfix. Okay, and then you continue your scan, there is nothing. So it's our stop sign again, okay? And what you need to do, you need to keep popping all of the operators out of the stack and apply it to the postfix expression until you empty your stack out. Okay, so that's overall our algorithm to do the conversion from infix to postfix expression, okay? So here, once again, we apply a stack. And this time the stack is a character stack. Okay, so that's the general idea about infix to postfix conversion, and the slides that we just went over discuss the first part, and here's the remaining part, is it? So the key point is whenever you have an operator, is it? So the tokens and operators in, what you need to do is that, okay, while stack is not empty, and the token doesn't have higher precedence than the top of the stack. And here, be careful, it's a loop. So you need to keep checking your stack with the top of your stack. Okay, if it meets this while condition, it means it doesn't have higher precedence and not empty the both condition, then you need to keep pop and add it to the postfix expression. Okay. And then after you finish the loop, then you get your token back to the stack. Okay. And after everything, then you need to empty and add it to the postfix. Okay, so that's the algorithm itself, and we already went over. And what's the next? It shows the examples, and after class, if you're interested, and you can keep tracking, keep tracing it. And here's some more exercise, and you can try, okay, after class at home. And we learned like how to evaluate from postfix to the result, to the arithmetic expression result. So we learned how to evaluate postfix, is it? And we also learned how to convert infix to postfix, is it? So if you combine both together, then basically you can write, and we also learned the Java FX, is it? The GUI, Java GUI part. So after this, basically what you can do after you go home is, if you have plenty of time, you can try to write a simple calculator. And with the simple calculator, it allows you to enter numbers, expressions in infix format. And then you can first do infix to postfix conversion, and then you apply the postfix evaluation, is it, to find the result. So basically, after we learn both of these two algorithms, and plus the previous knowledge about the Java FX, we can write some simple interactive calculator application. Let me stop sharing, and let's also going to resume the recording and share our screen. Okay, so over here, what we are going to see, we can take a look at our code. It's a pretty long code, okay? And we are going to read our postfix. So the first one is about postfix evaluation. Oh, regarding post, I forgot to mention another one. For the postfix, there is another name, we call it RPN. So postfix, a lot of time you will also, mathematician also call it RPN. RPN, it means reverse. Reverse. P means Poland. That's because the postfix expression was first proposed by Polish mathematicians. So that's why we call it reverse, not Poland, reverse Polish notation, and represents notation. So if you see RPN expression, basically it means the postfix expression, and within it, it doesn't have any of the parentheses, okay? And the operator is always after the two numbers. And what here we are going to see is we are going to read the file. The file is contains a number of expressions, and each one in a line. and it has postfix expression. Okay, so we are going to get our file, and we are going to do line by line reading. So we get every single line. And get every single line. So what next, what we are going to do is we have a function called evaluate. And basically what this function does is it's going to evaluate the postfix, okay? And it will return the result. So the majority part of this program is about this evaluation function, the evaluate method. And over here, we also have quite a number of try-catch block. That's because of the file handling, okay? And we already learned file handling exception, so you can review that also. And for our postfix expression evaluation, you remember each time when we do the algorithm, we need to find if the string literal is a number or if it is an operator. So we need some utility function to do the checking to see if your token is number or not. So basically this function is number, does that job. So it checks if your string token is a number or not, okay? And it also does the conversion, okay? Get your number out. And if it is a number, and then it can do something. So then that's its main part is about this evaluation function. So what this evaluation function does is it's going to have the postfix expression as the input. And it follows the algorithm that we just discussed and do the calculation. And once again, you see the strings split function is it to get each of the token out, okay? And if it is a number, is it we are going to convert the string literal version to a number, and in this case we deal with double, is it? And we push it to stack, okay? And it says if the token length is only 1, that means it may be an operator, is it? So if it is an operator, then what you need to do is here it says you need to pop number out, is it? So I first need to copy is it to get the top number, and then I need to pop it out and get the number and pop it out. And in case your postfix expression is not correct, is it? So over here, we also report the error, okay? And after you get that, then you can apply whatever the operation is it? It's plus, minus, or multiplication or division, is it? And if your postfix has some wrongdoing, it will also report error, okay? So and then next we push the result back, is it? So you keep doing within the loop like our algorithm shows. And after you reach the end of the expression, and you just get to the last item out, is it? So this program, you see, it also can detect of the error expression in your postfix. Okay, so that's a major part of this function. So this function does the postfix evaluation algorithm. And then in main, what we are going to do is we get each line, and then we call this evaluation method to do the calculation, and then you can get the result, is it? So at home, what you can do if you're interested, you can write your simple calculator application, and first you can try using this program to just do postfix evaluation to do a try. And then next, let me first stop sharing, going to resume recording. And we are going to see the Java coding part for infix to postfix. And this one is pretty similar as the other one. So this time our file will have infix expression, okay? Or we just enter, oh, okay, here is, we enter the infix expression, and then we are going to store all of our postfix expression to a file, okay? So what here we are going to do is we read the line, read a line of infix expression, is it? And then we call the function process expression. But basically what this one does is it converts the infix to postfix expression, okay? So the major function is the infix, is this method, is this process expression, okay? So the number is pretty similar as what we just saw. And over here, we also need another utility function called isOperator. And this one is also pretty straightforward. And the other utility function we have here is we have the higher precedence because we need to compare the two operators. Is that when we add the operator to the stack? So we provide this utility function also. So the major thing over here is we have the process expression. And for our infix expression, we use string, okay? And for our postfix, we use a string builder. And previously, when we discussed class, we also know string is a immutable class, okay? So with immutable class, what that means is you cannot modify the instance once it's created. So it doesn't have any set function. And the string builder is a mutable class. So string builder, after you create an instance, you can still modify it. So it does provide a set function. So in this regarding, our string builder has a bunch of like insert or add function dealing with string, okay, and also delete function. So you can modify. So that's just a review of our previous discussion. So let's see, so this time, like the algorithm said, we have a stack class, a character stack. So the stack is a character stack. So over here, I just use the Java libraries stack class. So we have a character stack, okay? And then we are going to do the scan token. So it's pretty similar as the previous one. And we determine if it's number or token, is it? And if it's number, you're going to directly add it to the postfix, is it? So that's why here our string builder postfix expression, and it's going to be called with the append function. As if for string, you don't have append function, but for string builder, you can call the append, is it? And we also use a space to separate different tokens. So you append the token, and after that, you apply the empty space. And then if the token is an operator, is it? If the token is an operator, what we need to do is over here, then we need to get it to the stack, is it? Or pop it out, so it depends, is it? So like over here says if it's left parentheses, then you just push it to the stack. And if it is right parentheses, then it's pretty straightforward. You just keep popping, is it? You get all of the operators out of the stack and apply it to the postfix, is it? Until the stack is empty. Okay, and here, once again, I like what we discussed yesterday. Is this kind of while loop also used a lot. With the stack application, you have the while loop and the while stack is not empty, is it? You check this condition. And then you do some pop and some pip operation. Okay, so this used quite often. And then next, if it is an operator, is it? Then we need to check, you remember, need to check the higher precedence, compare the operator, is it? So if the token doesn't have higher precedence, then whatever is the top on the stack, then you need to get the top items out and append the top operator to your postfix, is it? Yeah, so, and after everything, then you just keep popping off the remaining items out and append them to the postfix, is it? So here, once again, you see we use the while not empty loop and plus the pick and the pop with the application. So let's stop this. Can try with a small Java app. Basically, later on you will see, like after this kind of that, you can also, if you learn like like Android, it's easy to convert it to Android app. As well, like the calculator, that, and you have your screen designed a calculator. So you first the input is infix expression. Okay, and you apply the infix to postfix in your program, and then you apply postfix evaluation. Is it? And you can get the result. So basically, you can create some small calculator. Basically, right now we have the capability to do this. Okay, and that may be some interesting small project you can try.